So since we are on the aldehydes and ketones chapter, this is a reaction of aldehydes and ketones, of course. So which means that we need to know how to make this, which we know that this functional group is called an imine, and imines can be formed from carbonyls, okay, like this. So this is kind of where we are going. And if you remember, we made this one, and if you've seen all the videos, if you haven't, let me tell you, you will find this in the aldehydes and ketones synthesis, okay. And I think this is synthesis 1, but I'll write it over here again, okay, just in case you missed that video. So anyway, so which means we have to make this ketone over here, which is not, of course, it cannot be on this carbon, that would be too many bonds, but it's over here, right? So which means we need to know how to add a ketone there. So we're not adding any carbons, right? So that's you know, a different kind of chemistry if we were adding carbons. So which means we're just adding a functional group. And so then here we need to get this one from the alcohol, because that's how we usually get ketones like this, is by oxidation. So which means we need to get an alcohol at that location. So if we need to get an alcohol there, it means either we need a double bond or we need a bromine on there to do substitution, or a double bond to do addition reaction. So that's how we are going to start, okay? And so we have done this reaction before, so I will just go a little bit faster on this one. So for an alkane, there's really not much you can do except for, you know, free radical reaction. So here we're going to go ahead and do the free radical, which is bromine, and then you use light or heat or anything like that in order to get bromine. Now bromine is very selective, so you get only one product, which is going to be the most stable radical that's formed, which is tertiary, okay? And so that's the only product you want, and you know that you have to select reactions like that, which will give you the least number of products, okay? So you don't have to worry about separation or losing any of your product. Okay, so now we don't need that bromine there. We actually need to get something over here. So the best thing to do is going to be to remove the bromine, so you get a double bond here, right? So that's what we're going to do now. Let me erase all of this. And so to remove the bromine, you need to go ahead and do an elimination. Now remember this double bond that you're going to form here, okay? This double bond is Zaitse's double bond, or Zaitse's product. So the Hoffman product would be if the double bond was on the methyl group, okay, this kind. So we don't need this product. So which means what I'm trying to tell you here is you have to be careful in the kind of eliminating reagent that you need, which is a strong base in this case. So you can go ahead and use ethoxide or methoxide and then heat, okay? You need a small base. If you use a bulky base, you're going to get the Hoffman product. If you use a small base and heat, you're going to get the Zaitse's product, okay? And that's what we want. So now that we have our double bond, now the next step that we need to do here is to get an alcohol. So this is what I was talking about here, right? That we need an alcohol there. So now in this case, this is going to be anti-Markovnikov addition, because here you have more hydrogen on this carbon than that one, and that's anti-Markovnikov. Let me write here for Zaitse's also. So to get anti-Markovnikov, you need to have hydroboration, so BH3, THF, and then you need to work it up with hydrogen peroxide and a base, okay? So that's how you get the alcohol. Now from the alcohol to ketone is very easy, because all you need to do is oxidation, right? So now you end up getting your ketone. So this much we have done in that synthesis video that I've posted for you already. And in case you're wondering, well, couldn't she find something new? Well, actually, the reaction did go all the way to imine. I just stopped it to show you how to get a ketone in the beginning. Okay, so now the last step that we have to do is go from the ketone to the imine. And yes, that's only one step, okay, from here to here. And I'll draw that in red because this is all separate out. And so here then we just need ammonia because we don't need anything else on the nitrogen. Nitrogen has one hydrogen. So when you're forming an amine, you need to make sure that there are two hydrogens on there. So two hydrogen and a hydrogen. So instead of writing that, just go ahead and write ammonia, okay, for that, and that's good enough. And if you feel like doing this, and it's entirely up to you, I don't give you less credit or more credit. But if you want to write H3O plus, you can, because generally for all of these reactions, the second one, except for the free radical, usually you have to, wash with water. In some cases, bases, like in hydroboration. But anyhow, so that is it. That is how you will make an imine, okay, from the cyclohexane.